Welcome to the first lecture in Fundamental of Electronics. We will start our discussion on semiconductors. Before we begin in discussing the semiconductors in details, first we will see a little bit background of the atom in very brief. Any matter is made up of atoms. Now these atoms are thought to be in the earlier days that it cannot be splitted into small portions or regions. However, the atoms are now invented to be broke into the different small particles which are known as electrons, protons and neutrons, except the normal hydrogen which does not have a neutron. So this is an exception. So generally a matter is made up of atoms, and atoms are made up of electron, proton and neutron. We have studied in our 12th standard that the periodic table, which is consisting of various elements, all the elements that are present in this earth, we have included all the elements in the periodic table, and these elements which are included in the periodic table has been assigned a definite position depending upon its unique atomic structure. All atoms within a given element have the same number of protons. So when the element is fixed, that is a given element, if we see the atoms, it will have the same number of protons. Atom is not a single particle but made up of small dense nucleus around which electrons orbit at a greater distance. So we can think an atom with nucleus at the center, and the electrons will be revolving around the nucleus at a greater distance. So the distance from the nucleus to electron will be more. The first model which is very famous is the Bohr model, famously known as the Bohr model, which is depend upon the planetary model system. So like our solar system is there, which is having the sun at the center, and all the planets like the Earth, Mars and Jupiter, which revolve around the sun. In the similar way, the Bohr model, which says that the electron revolves around the nucleus, similar to the solar system. So the Bohr model, which is given by Niels Bohr, is the most famous model and oftenly used to describe the atomic structure. The other model which is more accurate in comparison to the Niels model is basically the quantum model, which is the modern model for the atom, but it is very difficult to visualize. Hence the quantum model are not oftenly used, rather than the Niels Bohr model is used in studying the fundamental of electronics. So the practical purpose in all electronics, we will use the Bohr model, which will be sufficient to describe any particle, any system, and it will be easy to visualize also. So mostly we will concentrate on the Bohr model and not the quantum model. However, in this video we will discuss a little bit background of the quantum model also. Let us first start the Bohr model and then we move to the quantum model. So at present we have known 118 elements, and these 118 elements will have unique atomic structure. We have seen or discussed that atom is made up of three elements, which are proton, neutron and electron. The neutrons are basically uncharged particles. They do not have any charge. Proton is positively charged, whereas electron is negatively charged. We have discussed that the center will be nucleus, and around which the electron will be revolving around about a certain distance. So here in this picture we can see that the neutron or the nucleus which is at the center, all the neutrons and protons will be there, and the electrons will be revolving around the nucleus. So this is our nucleus. Electrons will be revolving around it, and the protons and neutrons will be present in the nucleus. If we draw the Bohr model for hydrogen atom and the helium atom, we can see that both are unique in its nature. So all atom structure in the Bohr model is unique. However, in all the cases we will have the nucleus at the center and electron will be revolving through it, and this is the planetary atom model. Only the hydrogen atom will be little bit different, it is unique. Otherwise, the nucleus will consist of the protons and the neutrons, and the electrons will always revolve around the nucleus. Let us understand what is atomic number. So, as discussed that a periodic table will consist of all the elements and they will be arranged as per the atomic number. So, the atomic number are nothing but the number of protons in the nucleus. So counting the number of protons, that is equal to the atomic number of that particular element, that will be arranged in the periodic table, and the number of electrons will be equal to number of protons for any balanced or neutral atom. When we say a balanced or neutral atom, the number of protons is equal to number of electrons. So protons equal to electrons number, then it is known as the balanced, electrically balanced or neutral atom. However, if there is any change in the number, whether protons is more than electron or less than electron, then it will be a charged particle. So this is the periodic table where all the elements are arranged as per the atomic number. So hydrogen atomic number is 1, helium atomic number is 2, lithium, beryllium, then we have boron, carbon, nitrogen, oxygen, and so on. And all the elements are present in this periodic table, which is arranged as per the atomic number. So we see here that silicon, which is having the atomic number of 14, is located here. As we will be discussing the semiconductors, so we will generally focus on silicon and germanium. So the silicon is having atomic number of 14 and germanium is having the atomic number of 32. What is electron cell? We have discussed that the nucleus will be at the center and electrons will be near the nucleus, revolving at a greater distance, and all the electrons which are present near to the nucleus have less energy than those in more distant orbits. So here we have been shown the nucleus and the atomic structure of the silicon atom, and the electrons are revolving around the nucleus in certain orbits which are known as the cells. So we have cell number 1, cell number 2, cell number 3 and so on for different atoms. So they are revolving around the nucleus. If we talk about the energy, the electrons which are close to the nucleus will have less energy. So the energy will be less when the electrons are located close to the nucleus, and those which are far apart will have more energy. So once the electron is going far apart, will have more energy. Now separate and distinct energy values exist for electrons. So even the electrons will have separate and distinct energy that are revolving around the nucleus. So the orbit is basically the discrete distance which is correspond to certain energy level. So the energy level of the electrons and this energy level of the electrons are known as the orbit, which is at a certain distance from the nucleus. If we group the orbits in the energy level, that is known as the cell. Means if we take one orbit, lot of electrons will be there, and if we combine the orbits, grouping them, that is known as the cell. A given atom has fixed number of cells. So the number of cells in an atom is fixed, and each cell has a fixed number of electrons. So if we see here cell number 1, which is shown as the 2 electrons which is present in the cell number 1 is fixed for a given atom. So this is for the silicon atom. So we can see that for cell number 1 there are 2 electrons. So any cell will have a definite number of electrons, and for an atom it will have fixed number of cells. Cells will be designated as 1, 2 and 3. So which one is close to the nucleus. So one which is close to the nucleus is given as 1, and as we move away from the nucleus, we will be counting in ascending order 1, 2 and 3 that are known as the cell or otherwise the energy level. Now question is, what is the maximum number of electrons that can be present in each cell? So that is given by the formula. The maximum number of electrons in a particular cell is given by 2n square, where n is the cell number. That is, if we talk about the innermost cell, we will substitute n equal to 1 and we will get 2 electrons in the cell number 1. Whereas for cell number 2, we will have 8 electrons maximum. Cell number 3, we can have 18 electron maximum, and cell number 4, we can have 32 electrons maximum, and this can go on depending upon the cell number. When we discuss the semiconductors or in general electrons in the semiconductors, then the valence electrons plays a very important role. Now what is valence electrons? We have discussed that the electrons which are revolving around the nucleus will have some energy, and the electrons which are far from the orbit of the nucleus have higher energy. So one electron which is present far away from the nucleus will have high energy, and these electrons with respect to the nucleus will be less tightly bound. Means this will be loosely bound to the nucleus than the closer orbit electrons. So this is the nucleus and this is the electrons. So the electron which is located at the far end is having higher energy and it is less tightly bound compared to the electron which is present near the nucleus. This reason is that the force of attraction between the positively charged nucleus, so your nucleus will be positively charged because protons are present here, and the negatively charged electrons which is present in the orbits or the cells, and the electron which is present at the very far away from the nucleus will have more energy and it will be less tightly bound. The force of attraction will decrease and hence loosely bound as compared to the electron which is present nearby. So the outermost cell of any particular atom is known as the valence cell. So the cell which is present at the outermost region, that is known as the valence cell, and all the electrons which are present there in the outermost cell is known as the valence electrons. Now valence electrons have highest energy because it is present at the outermost orbit and it will be loosely bound to the atom. The reason is that both are having different charges. So electron will have negative charge and nucleus will have positive charge. Now these valence electrons, they are very important because they contribute to the chemical reaction and bonding within the material structure, and they determine the electrical properties. So valence electron will play a very important role in the chemical bonding and reaction within the material in general. Valence electron gains sufficient energy from external source. Now when we apply some external source in the material, then the valence electron which is present in the far orbit will be getting sufficient energy. Now energy will be there, and this energy will break the atom on the basis of conduction in the material. So based on the conduction, they will have certain energy and they will be free from the atom. So they will become free from the atom. What is ionization? So the atom which is absorbing the energy from the heat source or light. So these are the external sources. Either we have a light source or whether we have heat source, and these sources are given to the atom which is absorbing the energy. Then the electron energy will be raised. So electron energy will be raised, and the loosely bound valence electron which is at the very last orbit will jump to the higher energy level. So we have seen that the energy level is given as 1, 2, 3 and so on. So the last orbit n or the last energy cell n, where the electrons are present that are known as the valence electrons, and these electrons will have the maximum energy and it will be loosely bound. So what happens when external energy is given? These electrons will be free and it will jump to the higher energy level and it will escape the atom's influence. So it will go out of the influence of the atom. That is the reason these valence electron is very important in the conduction process or the chemical reaction process. The process of losing a valence electron due to the external heat source or light, when we have an external heat source or light, then that is known as the valence ionization process. So when we lose the valence electron, it is known as the ionization process, and the associated energy is known as the ionization energy. So when we lose the valence electron away from the atom, that is known as the ionization, and the energy which is responsible is known as the ionization energy. When we have a neutral atom, what is neutral atom? That number of protons and number of neutrons are equal. It is known as electrically balanced atom. Now become positively charged. This electron has become positively charged. Why? Because the protons are more than the electrons. So they have become positive ion. So neutral atom, that is electrically balanced atom, has become positively charged because the protons are more than the electrons are known as positive ion. And the electrons which have left or free from the atom, that are known as free electrons. So if we revise what is ionization, this is due to the heat source of light, which is the external source. The valence electron will leave the atom, that is known as the ionization, and whatever the energy is required for doing this, that is the valence electron to be free, that is known as the ionization energy. The neutral atom has become positively charged now, and that is known as the positive ion. So the atom has become an ion which is positively charged, and the electron which has left is known as the free electrons. If we take the reverse process, that the free electron collide and release energy, then the atom will be negative ion. So positive ion is when the energy is taken, protons is more than the electron. Negative ion is when the energy is released. So if you release the energy, then negative ion will be formed. If you take the energy to the atom, then it is positive ion, because it depends upon the number of protons and number of electrons. Now let us discuss the quantum model. The most recent model is the quantum model, which is more accurate, and it is a statistical model which is very difficult to visualize or understand. So quantum models are not taken into consideration when we teach the fundamental of electronics. We go with the Bohr model, and quantum model, however, is more accurate and recent. Now if we compare the quantum model to the Bohr model, what we find? Some similarities are there and some dissimilarities are there. Similarity is nucleus of proton and neutrons surrounded by the electrons. So when we talk about the planetary motion or planetary movement, we know that the nucleus is at the center and electrons are revolving around it. So here the position is same, that is the similarity from the Bohr model, the quantum model. We have the protons and neutrons and electrons are surrounding it. However, the dissimilarity is that the electrons do not exist in precise circular orbit as particles. In Bohr model, we have seen that the electrons are revolving the nucleus as a particle, but here the electron, we do not say that it is moving in the circular orbit precisely as the particle. So that is the dissimilarity from the Bohr model. So two important theories which is for the quantum model that we are going to discuss. The first one is known as the wave-particle duality. So wave-particle duality means the electron will have a dual characteristic similar to light. As we know, the light will have its wave and the particle nature, which is the photon. Similarly, the electron will have the wave nature as well as particle nature, which is the dual characteristic of the electron. The orbiting electrons, which is revolving around the nucleus, velocity considered to be the wavelength. So the electron which is revolving have some velocity which is considered to be the wavelength, which interfere with the neighboring electron waves by amplifying or cancelling it. So neighboring electron will have some wave, and those waves will interfere with the other electrons, either amplifying or cancelling it. That is the wave particle theory. So we have discussed the electron as a particle also, the electron as a wave also, and these waves will interact either to be amplifying or to cancel. This is known as wave-particle duality. Next theory which comes is the uncertainty principle. So the waves of the electrons will have its peak and valleys. How? Because we have seen that the electrons or any waves will have some peak and will have some valleys, and hence cannot determine its position at all instant of time. Heisenberg has given one important principle that simultaneous determination of position and velocity of an electron with certainty is impossible. So this principle goes with the uncertainty principle that given by Heisenberg. If we want to determine both the position and the velocity of an electron with extreme certainty, that is not possible. So the concept of probability cloud comes, which is the principle that the mathematical description of the electrons located in an atom. So we can't say the exact position of the electrons, rather than we can have some probability of the location of the electrons in an atom. Now, in quantum model, the cell or energy level, which we have represented with 1, 2 and 3 and so on, generally consists of 4 subcells called orbitals. These are defined as SPDF. These are represented with SPDF, the orbitals. So these are 4 subcells within the cell. Now, the maximum electron that can be present in the orbital. So the SPDF, which is within a cell, will have the maximum electrons as 2, 6, 10 and 14, which will be present in the SPDF orbitals. Let us understand the notation which we use for the quantum model. When we say 1s square, what is the meaning of 1s square? It means here we have 2, which is 2 electron in cell 1. So 1 represents the cell number and 2 represent the number of electrons, whereas the orbital is. So when we say 1s square, it means that the cell number is 1, number of electrons is 2, and the orbital is s. Similarly, if we say 2s square or 2p cube, it means the cell number is 2, total number of electrons 2 plus 3 is equal to 5, and 2 electrons are present in the s orbital and 3 electrons are present in the p orbital. So the quantum model takes the concept of subcells known as orbitals and that are known as SPDF, and the electrons will be present in these subcells, which will be given in the form of the notation 1s square, 2s square, 2p cube and so on. This was the example taken for the nitrogen atom. So nitrogen atom will have the electrons present in the form of the subcells as 1s square, then it will have 2s square and 2p cube. So here we have 5 electrons and here we have 2 electrons. So the cell number 1 will have 2 electrons and cell number 2 will have 5 electrons in total for the nitrogen atom. Now, if we understand the cell of the Bohr model is represented as 3D space, which is surrounding the atom, representing the mean energy of the electron cloud. So in the quantum model, we have the concept of electron cloud, which is the probability cloud, where we don't say the exact position of the electrons which are revolving the nucleus. We know that electrons are revolving the nucleus, but we do not know its position and the velocity at the same time. And hence we have the 3D representation of the electron around the nucleus. So we can see the quantum model of the sodium atom. So sodium atom quantum model is represented here, where the electron cloud, which is known as the probability cloud, definition is the area around an atom nucleus where the electron will probably be found. So we can't say the exact position, rather the probability of the presence of the electron we will be saying, and that is known as the probability cloud or the electron cloud. So if we discuss this quantum model, how the structure will be there in the 3D space, that is the s orbital, if we define, that is in the shape of a sphere. So s orbital will be in the form of a sphere with the nucleus in the center. So we know that nucleus will be at the center of an atom and s orbital will be in the form of spheres. Whereas energy level 1 is in the form of a solid, right? So if we see the center of this atom, it is in the form of it is a nucleus which is at the center, and then we have energy level 1 where the sphere of a solid, which is here, we can see it, and then energy level 2 we have the s orbital composed of spherical cells that are nested cells. Okay, whereas if we go for the p orbital of cell number 2, this is in the form of two ellipsoidal lobes known as the dumbbell cell structure. So we can see that all the electrons which are present, 2 electrons into py, and other thing is that one more thing important is that the p orbitals in each energy cell are oriented at right angle. So we have the concept of 3D space. So obviously we will be having something known as x-axis, y-axis and z-axis. So these axes will consist of the p orbitals 3 energy levels and right angle to the each will be right angle to each other, and the electrons will be represented here. So these are basically the dumbbell cell that we have discussed for the p orbitals. So we have the dumbbell cell, and we have certain solid structure, and then we have some spherical structure, and the electrons have the probability of the presence around the nucleus, which is the probability or the electron cloud. We can not certainly say its position, so we have gone with the concept of electron cloud or probability cloud for the quantum model. So quantum model are not that famous when we talk about the fundamental of electronics. In general, we go with the Bohr model because it is easy to visualize, easy to understand, and hence in this subject we will go with the Bohr model, and we will take the Bohr model as the reference to understand the electronics. Thank you for now. See you in the next lecture.